Command Query Responsibility Segregation (CQRS) is an architectural pattern that separates the operations that modify data, which are the commands, from the operations that retrieve data, which are the queries. This separation allows each to be optimized independently, improving performance, scalability, and maintainability. CQRS is often used in conjunction with event sourcing, where changes to the state of an application are stored as sequence of events. Let's look at the components of Command Query Responsibility Segregation (CQRS). The first one is the command model, or also called as the write model, which handles create, update, and delete operations. It is responsible for processing commands, validating them, and applying changes to the data. The next one is the query model, or also called as the read model. Optimized for read operations, it provides multiple views of the data that are tailored to different client needs. Next, we have the command handlers, components that handle command logic, typically by validating commands and then applying them to the right model. Then we have the event store. In systems using event sourcing, the event store captures all changes as events, which can then be replayed to restore or reconstruct the state of the right model. We also have the query handlers, components that handle data retrieval requests from the read model. Let's look at the benefits of CQRS. First is scalability. By separating read and write workloads, each can be scaled independently according to demand. We have optimized performance. Read and write data models can be optimized for their respective operations, improving overall system performance. We have improved security. Command and query operations can be secured differently according to their specific needs. And finally, we have flexibility. New read models can be added without impacting the write model, making it easier to evolve the application over time. Now, for drawbacks, first one is complexity. Introducing CQRS can add complexity to the system, especially in terms of deployment and maintenance. Your data synchronization, by keeping the write and read models synchronized, particularly in high volume environments, can be challenging. And finally, we have consistency. Immediate consistency is not guaranteed unless additional mechanisms are implemented, which can complicate the architecture further. Let's look at an example where we consider an e-commerce platform implementing CQRS. Now, the command model manages all updates related to user information, order placements, and inventory updates. We have the query model, which provides various views for different users, such as personalized product recommendations, order histories, and real-time inventory levels. And then we have the command handlers, which will validate and execute operations like placing an order, which involves checking product availability and processing payments. We then have the event store, which stores all events resulting from commands such as order placed and inventory adjusted. And finally, we have the query handlers, which retrieve data from displaying product details, user profiles, or order statuses based on the optimized query model. If you want to look at a real world analogy of this, we can think of CQRS can be likened to a restaurant kitchen, which is the command model, and its dining area, which is the query model. The kitchen handles the preparation and cooking of meals based on orders, which are the commands, while the dining area is set up to provide guests with a pleasant dining experience, which are the queries. Both areas function independently but serve the common goal of a well-operated restaurant. Let's look at some of the popular use cases. First, financial systems, where transaction integrity write and reporting read requirements are significantly different. We have the e-commerce applications, separate management of customer orders, which are write-heavy operations, and product browsing, which is read-heavy operations. We have gaming platforms, managing game state updates, which are the commands, and providing game statistics to leaderboard, which are the queries. CQRS is a powerful pattern when there are clear distinctions between how data is modified and how it is read, allowing each side to be tuned and scaled to best serve its purpose. It's particularly useful in scenarios where performance, scalability, and responsiveness are critical. If you have any questions, please leave them in the comments.